Hey guys, so in this video we will be going over the Python interview problem of reversing a sublist. So as you can see, we have one linked list here with the head node having a value of 11, followed by body nodes with values 16, 7, 5, and 3 respectively, and a tail node with a value of 2. So our job is to implement a function definition like so that after this is run, we return a linked list that reverses a specific sublist of the linked list depending on the parameters we pass in. So in this instance, we are looking at the fourth node and the sixth node, which are the start and end nodes of the sublist that we're supposed to reverse respectively. And in this case, we're looking at the node whose value has 5 because it's 1, 2, 3, 4 nodes from the head node, and 6 because it's 6 nodes from the head node, and it's the last node that we're reversing. So the node with the value 5 is at the end of the list, and the node with the value 2 is in the fourth node because we're actually reversing the values with each other. So in order to implement this code, we have to first sort of have a good picture idea of what's going on. Specifically, I wanted to talk about how this is done in a very general sense. So here I have 4 nodes, 3, 4, 5, and 6. These are the values of the nodes respectively. And we set the first node to the variable s and the second node to the variable t. And when we go through the code, it'll make a lot more sense why we're doing this. But we're basically taking the node that's under the variable t and throwing it over, tossing it over to the beginning of the sublist, so that when we get this node that is equal to t, we are moving it like so that the next node of t is now s. And this is the first iteration. And in the second iteration, we are throwing the value 5 because it's over t to the beginning of the sublist. And finally, t is allocated to 6, and we're throwing that value right before 5. So that using this method, we've effectively reversed the linked sublist 3, 4, 5, 6, and reversed it so that it looks like 6, 5, 4, 3. And this is a general idea of what's happening when we're using this reverse function definition. The second thing I wanted to bring up before we begin the implementation is to realize that this problem isn't dealing with the values of the nodes, but rather dealing with the arrows and the pointers of the nodes. And this is something that many people get confused with, and many people reason is why this is such a difficult problem, when it really, if you simplify it, it's all about moving the arrows and the next pointers to point to different nodes rather than changing the values of the nodes themselves in order to reverse them. And this will make a lot more sense as we go through the code, but this is a very general idea that I want people to understand before we go in. And finally, visualizing and drawing out the linked list in movement will help tremendously when working out these linked list problems. When you're in an interview setting and you're in front of a whiteboard, being able to draw the arrows and figure out the code from that is the most effective way, for me at least, to write code, because you're able to have a picture idea and you're able to translate that picture into code. And we'll be using that same picture concept when we create the code for reverse. So to begin this function definition, we will first set up the node itself. And the node is basically what values we will be, or rather what attributes we will be assigning to a typical node. Okay, so class node, we will have an init function definition, as we always have for defining nodes, where we have two parameters, self and value, which is initialized to none. And in this we'll have two attributes. Self.value is equal to value, and self.next is equal to none. So as of now, we've effectively created a node and assigned it so that we have a value from the first block of the node, and we have a next arrow that'll point to the second node in the sequence. Now, after we're done creating this class node, we can begin working on the function definition for reverse. So I'm going to call it reverse, and I'm going to have three parameters: head, start, and finish. Now, head is basically the first node of the linked list that we're trying to reverse. So in the example here, which we'll be using for the rest of the video, in L1, head is this node, and head will be assigned to 11 throughout the whole code. Start is this value, which is basically the first node in the sublist that will be reversed, and 6 is finish, which is the last node in the linked list that will be reversed. This is an important distinction to have, because once we assign start and finish, we can create a for loop that requires us to throw the values to the beginning of the sublist until we reach the finish node, which is, in this case, is the node that contains the value 2. So when we're throwing it, we'll be first throwing 3 to the beginning of 5, and then throwing 2 to the beginning right before 3, which will cause us to have nodes like that. And this will make a lot more sense when we actually get into the nitty-gritty of the code that we'll be implementing. So now that we've created the function definition header, we can now start by defining the dummy head. And the dummy head, and I've discussed this in the previous video where I talk about the interview problem regarding merging two linked lists. But the dummy head is basically a variable that we use so that we can completely remove having a separate conditional statement for the head node and the body nodes. So in this example where we're looking at linked list L1, this node is the head node, and we don't want to deal with this separately from these body nodes, but we sort of have to, because this head node has a special characteristic that there's no arrow pointing to it like there is for these body nodes. So for this reason, we should simply make it so that this head node is now a body node by creating a dummy node right before this head node that is now the new head. This will make it so that this head node is actually a body node when you look at the whole linked list. And this will be very important for simplifying our code and making it much easier to implement and understand. So once we've created dummy head, we should equate it to an iterator variable that we'll be discussing in the later code that's equal to p, and we'll set both of these equal to the node definition that we just defined earlier. So we have dummy head, and this is the head node that will be always at the head of our linked list no matter what, and we'll call it dummy head. Let me actually move it up here because this is permanent. This will always be the dummy head. And P, I'll write it below because this will change. And this is an iterator variable, and both of these are equal to node, which means that we are now able to give this the dot value and dot next characteristics that we've implemented in our class node definition. So this is what we have so far after implementing this line of code. The second thing we have to do is create a way to symbolize where the head is going to be. The head is this parameter, and it's basically the very first node of the linked list that we're passing into this reverse function definition. And in this example that I've created, that would be this node. This node is going to be the head node. And this is important to realize because the dummy node is not the head node, because the dummy node is a node that we created to act as a head node, but the real head node of the linked list that we're passing in is this one. So in order to create this, we will write some code that says dummy head dot next. So the arrow pointing to from the dummy head's second block to a new block, and this is going to be equal to p dot next, and p dot next is this, and both of these are equal to head. So what we can do now is, with this newly created second block, let me make this a little bit neater. With this newly created second block, we can now call this node head. Now that we have dummy head.next and dummy head defined, we can go ahead and look into where we want to start our for loop for our sublist. So let's go back to the visualization, and we can see that we need to reverse starting with the node whose value is 5 and end with the node whose value is 2, and reverse the node so that 5 is where 2 is, 2 is where 5 is, and 3 stays where it is, because that's how you reverse 5 through 2 to 2, 3, 5. Now, in order to reverse, we have to make sure that we're actually at the node that needs to be reversed. So in order to do this, we have to create some sort of for loop that says for each node, we will keep iterating through these nodes until we reach the start function, or the value of the start variable that we pass into reverse. And we can finally start reversing the linked list. So in order to implement this, we have to first create a for loop where for in range 1 to start, p equals p dot next. Now, there's two things to understand about this for loop. One is the underscore parameter, or the underscore in the for loop, which means that there's no iterator variable that we're going to use that's going to be used in the body statement. In other words, usually in Python you'll see something like for I in X print I, or something where you have to print the iterator statement until you reach a certain point. But in the case of linked lists, we usually don't have an iterator variable that we are looking at. Secondly, we have to understand that range is a built-in Python function that if there's two values that range is looking at, say 1 to 5, range will include 1 up to the number before the second value. In other words, the second value is excluded in the range. So range 1 to 5 will output 1, 2, 3, and 4, and 5 is not there. Similarly, if we do range 3 to 6, it will output 3, 4, and 5. So this means that we will do this statement until we hit the node right before the node that's declared as start. So in our situation, we have start initialized to 4. So that for loop that we just looked at will stop once we hit this node, because the start variable in this situation is pointing to the node whose value contains 5. So now that we have that established, we can look into p equals p.next, which, as I've discussed before, is the iterator variable that will move and hop to each node until it reaches the node right before the start node that we've declared. So in this example, p equals p.next will iterate 3 times from dummy head to the node that contains 11, and then from the node that contains 11 to the node that contains 16, and then from the node that contains 16 to the node that contains 7. 3 times, because remember, 1 to 4 means that we are only iterating for nodes 1, 2, and 3. So p equals p.next is p.next would be this. So p is effectively p.next. And we can erase p from here. And then p here will become p.next when range is at 2. So this is iteration 2, this is iteration 1, this is iteration 3. At iteration 2, p equals p.next a second time, so p will now be this value, and we can erase this p. And finally, p will be p.next a third time, so we can erase this p, and we can make p this value. So now that we've understood where the first node is that will begin the iteration process, we can now declare one more variable, which is s equals p.next, which is a variable that we'll be using as part of the reversal process that I'll explain later on. But s will always be in front of p.next when this value is declared, when this statement is declared. So we will put s right here, since this is p.next. So now that we have our return node or return linked list like so, with the code that we've wrote, we can finally start preparing the reversal process, which is going to be a separate for loop. So in order to do this, we will create a for loop, like so. For underscore in range finish minus start, finish being the third parameter, start being the second parameter of our reverse function definition. We will make t equal to s.next, s.next equal to t.next, t.next equal to p.next, and p.next equal to t. Now this, I don't expect anyone to understand this code off the bat, which is why I've created a visual for each step of this process so that you can understand what's going on and can implement it yourself when the time comes. So first, let's start with the first line of the for loop, which is t equals s dot next, which is basically initializing the variable t so that it's equal to whatever s dot next is pointing to. So s dot next is pointing to the node whose value contains 3. So as of now, s dot next is equal to this node. So t is going to equal that node. Now the next 3 lines are dealing with the arrows, and we're going to be making it so that these arrows point to different nodes so that they're effectively switched like that. So now that we have t equal to s dot next, we can look into s dot next equals t dot next. And s dot next is this arrow, and we've actually moved it so that s dot next equals t dot next. T dot next is this node, since t dot next is pointing to this node, and s dot next is this arrow, which we're actually moving to point, instead of pointing to the node that has t, is pointing to the node that t dot next is pointing to. So I've denoted it with this blue arrow, which changes the next node of s to point to the next node that t is pointing to, that the next node of t is pointing to. Now that we've done that, we can go to the next line, which says t dot next is equal to p dot next. And t dot next is this node in this second block. And instead of t dot next pointing to this node, we are moving it so that it's now pointing to the node that is defined by s, specifically the node that p dot next is pointing to. So p dot next is pointing to this node due to this, so t dot next is now going to point to s, which is t dot next, which is p dot next. Finally, p dot next is going to equal t. So p dot next, which used to point to this node, is now going to point to t, which is this node. So as you can see with the red arrow, we're moving it so that p dot next is pointing to t. Now that we've completed this for loop, we can simplify this formation. Since this looks like a bunch of jumbled arrows, you can see that p dot next is pointing to t, t dot next is pointing to s, and s dot next is pointing to this node. And we can simplify it like so, where p is pointing to t, p is pointing to t, t is pointing to s, t is pointing to s, and s is pointing to the node that contains the value 2. And we've effectively thrown the node that t is over, which is 3, we've thrown it over to the node right before 5. Like so. We've thrown 3 that was originally here over to the node before 5. Now, are we done yet? No, because our finish variable is declared to equal 6, so we still have to reverse the 6th node of the linked list. And as you can see from our for loop, this for loop will run until finish minus start. So finish was 6 and start was 4. So this is basically saying for underscore in range 2. And a little side note about a range with a single number is that it will always begin with 0, and it will go up until the number that we've passed in, excluding it. So 2 is not included in the range 2. So we're only looking at 0 and 1. So this is basically saying that this for loop is going to run twice, which makes sense because our first iteration, iteration 0, threw this node right before 5, and our second iteration is expected to throw this node right before 3. Now, how do we throw this if t isn't here? Well, this is because our first line of our for loop does that for us, which is that t is equal to s.next. So t is going to move from its original area to wherever s.next is. So s.next is pointing to the node whose value contains 2, so t is going to be here. As you can see in this image, we are moving t to equal s.next. And one important thing to realize is that, which might go over people's heads when looking at this, is that t or s.next on the left side of this equality statement is being changed, which is why we're not messing with s.next with this statement, because we're basically saying make t equal to whatever value s.next is equal to. And since s.next is equal to the node whose value contains 2, we are saying that make t equal to the node that s.next is pointing to. Similarly, s.next, t.next, and p.next are all pointers that we are moving from their original places to point to the nodes that t.next, p.next, and t are pointing to respectively. So now that we've moved t over, we can now do this for loop all over again with iteration 1, where s.next is equal to p.next. So s.next, which was originally pointing to t, is now going to point to t.next, which is interestingly null. T.next is null because there's no nodes that come after the node that contains 2, and the node that contains 2 is actually a tail node. So that's alright, that's okay to do. So s.next is going to point to t.next, which is pointing to null, and then t.next is going to point to p.next. So t.next is this purple arrow that was originally pointing to null is now going to point to whatever p.next is, and p.next is pointing to this node. And finally, p.next is equal to t. And p.next, which was originally pointing to this node, is now pointing to t. And we can simplify this like we did with the iteration 0, where p, since the p node is pointing to the t node, and the t node is pointing to the node whose value contains 3, and the node whose value contains 3 points to the node whose value is 5, we can simplify this to make it look neater and effectively make it like this, where we've actually thrown the node whose value contains 2 over and made it go right before the node whose value contains 3, and we can see that here. And that's it. We've actually reversed the sublist rather, for the nodes 4 to 6, and made it so that they look like this. And that's the end of the code. And the last step, after we're done with that step, is to return whatever we've created, which is return dummy head dot next. And that's how you reverse a sublist. Let me know if you found that informative and you've learned something. What I recommend is that you work through this process yourself and you try to make it make sense in your own mind. So I would draw it out and move these arrows like I've done. And then once you've been able to make these arrows move, try to write the code for it and make sure that that code will remain true even after you iterate more than once. So one question that I might have is, why can't we do t.next is equal to s? So instead of t.next is equal to p.next, why can't we make it equal to s, since t.next is pointing to s? Well, this is a good question, and the answer is that because s is not always going to be the node after p.next. However, p.next is always going to be the node that t.next has to point to. So in iteration 0, for example, we can see that t.next does point to s. But once we go to iteration 1 and we see that t.next is s, actually is not actually in front of p, s is actually here, we can see that t.next equals s no longer holds true, because we're basically moving the t.next arrow to point to this node instead of this node, and we're not actually reversing the sublist correctly. So being able to understand that your drawing has to hold true for multiple iterations, this is a very, 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 very specific implementation that requires that you equal these nodes specifically and in the same order. So hope you enjoyed, and let me know how it goes. Thank you for watching, and hope to see you in the next video.